are discussing the module 7 of the Organic Chemical Technology course, and the lecture 5 will be discussing about the ethylene derivatives, ethylene oxide, ethylene glycol, ethylene dichloride, which is major outlet for vinyl chloride, and some of the other actually the ethylene derivatives which we will be discussing. One is the ethanol, because the importance of ethanol is always there, because one of the source of the ethylene is still ethanol in India. So, and another important chemicals which will be discussing about the acetaldehyde. Already you have discussed about the vinyl acetate in detail. So, acetaldehyde, that is one of the another very important derivatives of ethylene. This will be the coverage of the lecture: introduction, product profile of ethylene, installed capacity and the production of the important ethylene and ethylene derivatives in India, world ethylene supply demand, world ethylene capacity, and what are the products, the feedstock for the ethylene, ethylene oxide and ethylene glycol, because this is the ethylene oxide and MEG plant, that is integral part of the large all the petrochemical complexes, whether it is the Reliance or Panipat refinery, where they are having the cracker, IPCL, or even in case of the Gandhar unit of the Reliance Industries. In all the cases, we are making the ethylene oxide from the ethylene and then the ethylene glycol. Another major outlet for the ethylene, that has been the vinyl chloride through the ethylene dichloride, cracking of ethylene dichloride, then vinyl chloride, which is the monomer for the polyvinyl chloride, one of the largest consumed polymer that we are using in the different application. Another product, vinyl acetate, already we discussed about the vinyl acetate while discussing the synthesis gas, because vinyl acetate both the routes are available, and some of the units which are making the ethanol from the molasses route, they are also making the vinyl acetate. Ethanol, why ethanol here? I am discussing the ethanol that has been the one of the major route for ethylene even before coming of the petrochemical. Then the acetaldehyde. Ethylene is one of the most versatile chemicals, and its production has steadily increased over the years, and ethylene is called as a king of chemicals and surpass all organic chemicals in production and in amount sold. Ethylene is the basic building for a large number of the petrochemicals. Because of its ready availability at low cost and high purity and reactivity, ethylene has become one of the important raw materials for large number of the petrochemicals and the products. Ethylene has replaced the earliest route of the production of vinyl chloride, acetaldehyde, vinyl acetate and other chemicals through the ester route. As I told you earlier also, the birth of the chemical was actually through the calcium carbide route, ethylene route, but now because of the coming of the large number of the complexes and at the same time the availability of the ethanol, now the ethylene that is being manufactured either through the from the cracker plant or from the molasses route, because again molasses route, the cost of production is higher in comparison to the petrochemical route, but with the rising cost of the crude oil and the at the same time basic raw material for the petrochemical complexes, the molasses route of the ethanol and from ethanol to ethylene, that can play a very important role. Large tonnage of the ethylene is being used for the manufacture of the polyethylene. Polyethylene is the one of the major product apart from the polyvinyl chloride, because the polyethylene that has revolutionized the packaging industry ethylene oxide, ethylene glycol, and also the styrene, ethyl benzene we are making, where we need the ethylene. So, that is also one of the major outlet for the ethylene, and this is the reason why the some of the petrochemicals, they are also just like Indian Oil Corporation, Panipat, they are going for the manufacture of the SBR. But earlier route of the styrene, that was the again through the your ethanol route. These are the some of the major outlet for the ethylene. Apart from the, as I told you the earlier, that the polyethylene, that is one of the major product of any petrochemical complex, LDDP, and the various grade of the polyethylene that is available. Again, detail of the polyethylene that will be discussed while discussing the polymer. So, these are the some of the grades of the LDP, polyethylene, LDP, LLDP or the HDP. Another major outlet which is finding major application in the chemical industry, that is ethylene oxide and ethylene glycol. You see the ethylene glycol, that is one of the major chemical that we are using in the manufacture of the polyester, and so this is the importance in case of the another important outlet that has been the ethoxylate that we are making, which is going to the surfactant industry. Acetaldehyde, as I told you, the acetaldehyde, that is one of the important organic chemical that we are making from the ethylene, and so the uses are acetic acid, peracetic acid, acetic anhydride, which is again we are getting used in case of the cellulose rayon. From ethyl alcohol, cellulose stage vinyl, it may be acetaldehyde. From the ethyl alcohol route also you can make, because both the routes are available, olefins and butenes, synthetic detergent, oxo alcohols, etc. Chlorinated solvent, ethyl chloride, vinyl acetate and vinyl chloride. These are the major actually outlet for the. This is the installed capacity while discussing the your petrochemical, the overview of the petrochemical, and then the starting the raw material and the various product that we are giving. These are the some of the major outlet for the from the ethylene derivatives which are making ethylene, ethylene oxide. This is the installed capacity, this is the production, ethylene oxide, monoethylene glycol. During the MEG manufacture, we are getting both the MEG, DEG and TEG. Then the acetaldehyde, acetic anhydride, ethanolamine. As I told you that ethanolamine is finding wide application for the removal of the sour gases, and then the ethyl acetate. These are the some of the major ethylene complexes in the world. Already I discussed while discussing the cracker plant. This is the installed capacity of the ethylene. This is the how the raw material, again some of the things we discuss about the while discussing the cracker plant, because the basic source is the mother plant is the naphtha cracker or the gas cracker, from where we are getting the ethylene. So, again the major product is the 52% is from the naphtha, rest of the others natural gas, ethane, propane, butane, or it may be the gas oil, and this is the demand of the end use that you are having. So, one of the major use the this is the about the polyethylene. You see the major portion that is going to the polyethylene, then the ethylene dichloride for making of the PVC. So, these are the some of the major outlet for the ethylene, and this is the reason why the importance of the ethylene is there. Again the global ethylene capacity, that is the how the capacity change that is there, addition of the capacity is there. World ethylene capacity, Middle East, this is the European Union, North America and the rest of the world. So, the major North America is still, it is the major part. The ethylene, basic roots of ethylene, as I told you, the earlier method of getting the ethylene, that was the fermentation of molasses to ethanol, and then dehydrogenation of the ethanol to ethylene. And the another route that is there is the thermal cracking of the alkanes, naphtha and gas oil. The FCC gases, because as I while discussing the C4 C5 gases, I discussed that the FCC gases, they contain dilute stream of the ethylene also, although it is not being recovered, but in the future definitely that may play important role, the recovery of the ethylene from the FCC gases. Another route for the getting of the, that was the apart from these three process, the dehydrogenation process of the paraffins, which we are using for the propylene also. So, dehydrogenation of the ethane, that can be a, that is the on purpose, means the in the plant itself ethylene is that you can produce the without going for the cracking, dehydrogenation. So, as I told, the major portion of the ethylene is still made through the cracking of the naphtha and natural gas, ethane and propane. In India, naphtha and natural gas are the two major sources of the ethylene. Apart from the some of the units which are still making the ethylene from the molasses route from the ethanol, and two major plants which are there and which played very important role in the development of the chemical industry in India, that is the Indian glycol and the VAM organic now jubilant organisms, which are still operating, and that is a VAM or jubilant organism, that is large integrated plant we are having. And so I will discuss, while discussing the ethanol, what are the product profile of the alcohol to ethylene route. Let us discuss about the ethylene oxide, because most of the cases wherever we are having the one major plant is polyethylene plant, another is the ethylene oxide. PVC, ethylene dichloride, not everywhere, because they need the additional one huge amount of the chlorine also. But the you see the PVC, that is one of the very important actually outlet for the ethylene also. So, let us discuss now the ethylene oxide. Ethylene oxide is one of the important petrochemical intermediate. Some of the major ethylene oxide derivatives in the manufacture of the ethylene glycols, as I told you, the MEG, DG, TG, glycol ethers, which is made by reaction of the ethylene oxide and alcohol. Ethanolamines, surfactant industry, one of the largest user of the ethylene oxide, where the ethylene oxide, that is where we are making the ethoxylate, that is more value added product, and this is the Indian glycol, they are making the ethoxylate. These are the major actually units which are based on the naphtha and the natural gas, which are having the ethylene oxide plant at the Reliance Industry, Vadodara Hajra plant, Nagothane plant, and the Gandhar plant. These are all units are making ethylene oxide. IOC Panipat refinery, molasses based plant are Indian glycol and SM Dichem. New plant ONGC and Brahmaputra Kak. ONGC also going to have one petrochemical complex near Gandhar, where the Reliance Industry, they have already having a big naphtha gas cracker plant, and then the large number of the products, they are petrochemicals, and the finished product they are manufacturing. These are the the major outlet of the products which we are getting from the ethylene oxide. Ethanolamines, monoethylene glycol, diethylene glycol, triethylene glycol, that is detergent, soap solvent, cosmetics, morpholine, polyester, staple fiber, PET bottles, where we are using the MEG for making the PET resins, because we are having the polyester, that is going to the your synthetic fiber, and PET resin, that is going for the packaging, means bottles and other containers we are making from the PET. So, film are the PET films, coolant, pesticides, rubber compounding, plasticizer, polyurethane, alkyl reagent and the natural gas condensing agents. Polyethylene glycol, non-ionic surfactants, ethoxylates and glycol ether. These are the other some of the outlet for the more value added product of the ethylene, where they are finding application and the pharmaceutical industry, fluid, textile, dyes, then the brake fluid, that is glycol ether that we are using. These are the how the ethylene oxide use pattern. That the major portion you see the ethylene glycols, because during the process as I told you all the three are found, but you can optimize the condition of the so that the higher portion of the major portion is the MEG by adjusting the water to U ratio. So, this is the how the and the one of the another major outlet as I told the surfactant industry and ethanol amine 7%. So, these are the some of the major outlet for ethylene oxide, and you can realize the importance of the ethylene oxide in the petrochemical industry. These are the product profile of the ethylene oxide. From the ethylene oxide, these are the major products derived from the, and they are finding the application in the various area: monoethylene glycol, diethylene glycol, triethylene glycol, polyethylene glycol, and the non-ionic surfactants, ethoxylate and the glycol ethers. These are the major outlet for ethylene oxide, and from where you can see the large number of the petrochemical intermediate that we are making. Now, let us discuss the process of the ethylene oxide. There are two processes, as chlorohydrin process and direct oxidation of the ethylene. Chlorohydrin process, in chlorohydrin process ethylene is reacted with chlorine and water to give an aqueous solution of ethylene chlorohydrin and hydrogen chloride, which after reacting with the calcium hydroxide produce ethylene oxide. This was the earlier process that was being used for the manufacture of the chlorohydrin route for the ethylene oxide, but you see the here it is the involvement of the chlorine is there, production of the hydrogen chloride there. So, highly corrosive nature is there, that has to be avoided, and so because of that reason now we are having the ethylene direct oxidation of the ethylene. This is the reaction that is taking place in case of the chlorohydrin process, and the chlorohydrin that is going for the manufacture of ethylene dioxide. So, corrosion problem, one another byproduct you can say they are waste you are generating, that the calcium chloride. So, these were the two major problems which led to the use of the oxidation process of the chlorine ethylene, sorry, not ethylene. Ethylene oxide by direct oxidation process, various steps involved in case of the ethylene oxide, ethylene by oxidation process, ethylene oxide synthesis, ethylene oxide scrubbing, because during the process lot of the CO2 is also evolved. So, CO2 that has to be separated by scrubbing, ethylene oxide purification and CO2 recovery section. So, these are the three major section in case of the your ethylene oxide by the oxidation process. In the direct oxidation process, ethylene after removal of the sulfur here also, and the oxygen produced by air separation, because the oxygen definitely that has to be from the air, and so they are reacted safely under optimum condition, because lot of the safety is involved here in case of the ethylene oxide process, because of the flammability of the ethylene and the oxygen mixture. So, the separation are reacted safely under optimum condition for making ethylene oxide in presence of the silver catalyst that we are using here, containing an initiator, which is usually alkaline earth or the alkaline metal deposited on solid support. This is the reaction that is taking place, and in the reaction if you see that we are also getting some of the side reactions also there. undesirable side reaction which are not unavoidable. This the CO2 formation, huge amount of the CO2 that is formed there in the process, and so that has to be removed continuously. So, this is the process we are having the flow diagram for making of the ethylene oxide, ethylene air inhibitor that is going to the fixed bed tubular reactor where the temperature around 200 to 300 degrees centigrade, cooler, then absorber as I told you the CO2 that has to be removed. So, the finally it is going to the steam stripper and ethylene oxide, heavy ends you are removing, and then the ethylene oxide you are getting as a top product from here. So, this is the actually the process flow diagram. This is the requirement of the raw material per ton of the ethylene oxide, ethylene air and the water. So, here one of the major problem, that is the side reaction which are there where the CO2 is formed or the formaldehyde is formed. So, that has to be minimized, but CO2 formation always be there as per the reaction, and so that has to be removed, and that can be stored, that can be utilized for some of the value added product. So, the reactor temperature is one of the most critical parameter in ethylene oxide synthesis and is measured at large number of the location in the catalyst bed, because temperature that is playing a very important role here, because we will have to suppress the side reaction which is taking place, and efficient and reliable heat transfer system is also very important. The flammability of ethylene oxide, as I told you, discussed by the safer condition that has to be provided, because the flammability of ethylene oxide poses a serious problem in the operation of the ethylene oxide. The main hazards in the ethylene oxide process are the potential formation of the flammable oxygen and hydrocarbon mixture and auto ignition of these oxygen hydrocarbon mixture. So, here proper precaution has to be taken, so that the, and as you know, the oxidation reaction, this is the oxidation reaction. So, always it will be exothermic and exothermic reaction. So, control of the temperature, that is very important, and that is why the monitoring of the temperature at the various section of the reactor, that is very important. This is the requirement of the ethylene oxide, the properties of the ethylene oxide that is required. So, the various appearance, water content, aldehyde, carbon dioxide, non-volatile residue, color. This is the ethylene glycol found of Reliance Industry, courtesy Reliance Industry, and I will be discussing now about the ethylene glycol plant, because that is one of the, again as I told you, the one of the major unit in case of the cracker plant or the petrochemical complex. Mono MEG, DG, TG, mono, di, tri, ethylene glycols, the major petrochemicals, and find application in manufacture of polyester, and as antifreeze accounts for 70% of the ethylene oxide production. Ethylene oxide preheated to 195 degrees centigrade, then the UO(H2) ratio, because here that is very important, the ratio of the ethylene oxide and water to maximize, because here our interest is to have more and more MEG and less DG and TG, but always that will be there, and so they will be as a byproduct. So, this is the reaction that is taking place during the manufacture of the ethylene glycol from the ethylene oxide, and so the here you see the various reaction that is taking place, MEG, DG. So, this is the how the why the we are controlling the ratio of the ethylene oxide to water to have the maximum MEG. This is the process flow diagram for MEG, and here if you see the ethylene oxide, then the water inhibitor that is going to the dilution, after dilution it is going to the glycol reactor. This is the temperature and your pressure condition, residence time is about this is the residence time, and then the this is the actually the multiple effect evaporator, and during the process, because here you will have to control the ethylene oxide to water ratio to maximize the yield of the MEG. So, this will go to multiple effect evaporator, dehydration, and then we will be getting the MEG, recycled water, that will go to the system, MEG, that will go to the MEG column, DG column, TG column. They are the three fractionating column where we are separating depending upon the boiling point. So, monoethanol glycol, ethylene diethylene glycol or the triethylene glycol heavy end. So, this is the process for the manufacture of the MEG. Here one of the very important parameter which you have to control for the maximize the production of MEG, that is the ethylene to water ratio. Now let us discuss another important petrochemical which is derived from ethylene, that is the phenyl chloride, which is being used for the manufacture of the polyvinyl chloride. So, vinyl chloride is one of the major ethylene derivative and has gained worldwide importance because of its industrial use as raw material for polyvinyl chloride polymer, the second largest tonnage commercial polymer after polyethylene. About 95% of the present vinyl chloride production worldwide is used in polymer production or the copolymer application. Another important use of the vinyl chloride is the production of the vinylene chloride, which is being used as the co-monomer in some of the synthetic fiber industry. These are the three technology available. Earlier route I discussed the ethylene route, and still one of the unit in India they are making vinyl chloride and the polyvinyl and the PVC from the ethylene route, that is the Serum Chemicals and Fertilizer at Kota unit. They are still making the PVC through this route. So, that was the older unit, and the second process that was developed in direct chlorination method, where the direct chlorination of the, but here again the HCl was formed, and so in order to avoid it, because the highly corrosive nature was there and the handling of the HCl. So, direct chlorination that has been replaced with the oxychlorination process, which is now being used in most of the petrochemical complexes. Vinyl chloride, as I told you, let us discuss about the historical background of the production of the vinyl chloride. Vinyl chloride has been made since 1930s from the calcium carbide route. That was the earlier route which was available, because if you are talking about the 1930s, no petrochemical complex, the petroleum refinery, that was the at the developing stage. The process involved the reaction of the ethylene with the hydrochloric acid in vapor phase over a catalyst mercury chloride supported on active carbon at a temperature of 370 degrees centigrade, and depending on the age of the catalyst. So, this was the actually the earlier route for making, and this is the reaction. We are getting this acetylene and acetylene after the chlorination, that HCl then it will go to for the formation of the vinyl chloride. So, direct chlorination process where we are using no, this is not the, we are not using the oxygen. So, if you see the reaction in case of the these two reaction, direct chlorination and the oxychlorination. Here again in case of the here HCl is also formed, but here in case of the oxychlorination, this HCl, whatever the HCl that is consumed in the process. So, final stage in case of the vinyl chloride is from whichever route you are getting the ethylene dichloride, then the cracking of the ethylene dichloride to your this vinyl chloride. In case of the vinyl chloride direct chlorination method, the first stage is the ethylene is reacted the chlorine in either liquid or vapor phase in presence of the ferric chloride to produce ethylene dichloride. Second stage, that is the cracking of the ethylene dichloride. So, the vinyl chloride is produced by pyrolysis of vaporized ethylene dichloride in a set of tubular furnaces at a temperature of about 400 to 500 degrees centigrade. So, this is the process that was being used in case of the direct chlorination of the ethylene for making the vinyl chloride. This is the series because the reaction radical change, that is initiation, propagation and termination stage are there, and so these are the various reactions that is taking place. Here you see the one of the major constant, that was the production of the HCl, but in the other process the HCl that is being used in the process itself. Now let us discuss about the oxychlorination process, because now all the vinyl chloride manufacturing, they are based on the oxychlorination process. The original process of manufacture of vinyl chloride by ethylene chlorination and cracking of ethylene dichloride has been replaced by oxychlorination process, in which no hydrochloric acid form as a byproduct, which was a problem in case of the direct chlorination process. Already we have I discussed that point. In case of the oxychlorination process, the process involves production of ethylene dichloride by exothermic reaction of ethylene, hydrochloric acid and oxygen, because here the whatever the hydrochloric acid is produced in the process, that is being utilized. So, liquid phase or the vapor phase reaction that may be there. So, this is the how the reaction that is the various condition that is involved. This is the reactor, typical reactor which we are getting ethylene and chlorine, and then it is going to the various stages of the, and then the ethylene dichloride, then the cracking, you are getting the vinyl chloride and the HCl which you are getting here after the cracking of EDC, that will go to the, that will be recycled, that will be used in the system. So, this is the chlorination that is taking place, and the ethylene HCl that this HCl that will be recycled in the system, and so the ethylene dichloride finally it will go for the cracking process. Already I have discussed about the vinyl acetate, but only I am mentioning here because one of the route is the ethylene route is also for making of the vinyl acetate, which the in case of the VAM organic or jubilant organic, they are making the vinyl acetate that route. So, it is one of the very important derivatives of ethylene which is used as intermediate for manufacture of the polyvinyl chloride, polyvinyl acetate, polyvinyl butyl. Global use pattern, this is the adhesives, paints, textile, plastic, paper and board. Consumption pattern of the vinyl acetate in India is this is the polyvinyl acetate emulsion and resin, that is 50%, that is a major outlay. Polyvinyl alcohol 25%, ethylene vinyl acetate 10%, others 15%. This is the use pattern of the. So, these are the two routes, again the same ethylene route which I told you, that the acetylene, that was the earlier route, and the many of the petrochemicals which are now we are making, because now the 90% of the chemicals we are organic chemicals we are manufacturing from the petrochemical, but earlier it was the acetylene route which was available for making a large number of the chemicals. So, ethylene route, and that is now what we are using, and the acetylene route. Ethylene route means the why the ethylene route I am telling here, because ethylene, for getting ethylene to vinyl acetate, ethanol route that is also available. This is the about the process technology. Ethylene route has replaced the traditional process of manufacture of vinyl acetate from the acetylene route. The production of the vinyl acetate through acetylene route, which was developed by Vacuum in 1930, involves reaction of the acetylene and acetic acid in liquid phase. So, that process that has been replaced with the use of the ethylene in the as a raw material. So, vinyl acetate is made by reaction of ethylene with acetic acid by liquid phase process or by vapor phase process in presence of the pyrogen and cupric chloride catalyst. This is the process which are now being used for the even the units which are making the vinyl acetate from the ethylene, from molasses route alcohol to ethylene. So, they are using this process. These are the reactions, series of reaction that is taking place, and the catalysts which are using pyrogen catalyst. Use of vinyl acetate, already I have discussed about the what are the various uses of the vinyl acetate. The huge outlet is there for the vinyl acetate, and the importance of the already I discussed in the previous lecture also. Now, let us discuss ethanol, because here I am discussing ethanol separately again, because we discuss about the ethanol while discussing the sugar and the fermentation industry, but here I am discussing the ethanol because there is an alternative route for making the ethanol through the ethylene route, which is not being practiced in India, but at the same time ethanol is not important from the beverage point of view. It is also one of the very important feedstock. So, ethanol, apart from its major use as a beverage, is one of the most versatile chemicals and is one of the basic building blocks for the organic chemical industry, and ethanol is generally produced by fermentation of molasses due to development of the petrochemical industry and availability of the ethylene. Now, ethylene provides another major route for the formation of the ethanol. Ethanol in India is still manufactured through the molasses route. So, some of the important chemicals which are made through the petrochemical route are still made through the ethanol route, as I discussed while discussing the the raw material for the organic chemical industry. Ethylene from ethanol, that is providing a basic raw material for many of the intermediates which we are making from the ethylene from the your cracker plant which you are getting. This is the actually the process various a large number of the product which you are saying from here, that is the from, but only difference here, this is the from the ethanol route, ethanol tree you can say. Only difference from a petrochemical and this route is only that here from ethanol to ethylene. In case of the petrochemical, directly it will be from ethylene to ethanol. So, in case of the alcohol based chemical industry, what we are doing the going for the from the ethanol we are going for the ethylene, and from ethylene a large number of the products that we are making. Two important complexes which I told you I have been discussing time to time, because the nature has provided a alternative raw material. Only thing how to exploit those raw material, how to explore the possibility of these raw material, that is important. This was the reason why they even during the initial stages number of the plants, because the alcohol is available from the molasses route, they started manufacturing some of the very important chemical, organic chemical, and in this jubilant organisms and the Indian glycol casipose. These are the two other units, the Somaya organic in Barabanki. Now it is closed because of this some region, economic region. Another major unit was there which started making, because all our these 4 units were in UP, and because the UP that has been always the sugar producing state. Another is SD came, that was in Maharashtra. Maharashtra also the ethanol, because the sugar producing state is there, and so they are making from the ethanol to some of the chemical. So, for the ethanol, as I told you, the fermentation route, catalytic hydration of the ethylene or ethylene esterification and the hydrolysis. These are the 3 routes available, and so the first route is from the molasses route, and the second route that may be used for the making of the ethanol from the ethylene. So, this is the reaction that is taking place, the vapor phase hydration of the ethylene. I am not going in detail about the alcohol part, because again what we are interested from the petrochemical or organic chemical feedstock, that is the ethylene. So, ethylene, why to convert ethylene to ethanol again? Only I am saying that from the ethanol you can get back the ethylene, and so the how to get the ethylene from the ethanol, where we are having the molasses as raw material for ethylene. So, this is the process we are using in case of the ethanol by hydration, by vapor phase hydration of the ethylene, that we are getting the ethanol. This is the process that we are using for from the using the ethylene for making of the ethanol. Now, let us discuss one of the very important product of the ethylene, that is the acetaldehyde. Acetaldehyde is one of the most important intermediates for the manufacture of a large number of the organic chemicals like acetic acid, acetic anhydride, pentaethyl, butanol, peracetic acid, chloro, 2-ethylhexanol, pyridine, picolines, vinyl acetate, 1,3-butene, alcohol. You see the sum of the product where you are seeing, these are all major products which manufactured by jubilant organisms through the ethanol route, ethanol to. So, because they are the alternative route for making of the acetaldehyde. One is from the ethylene route, another is from the ethanol route. The process technology, the again here the same acetylene which I was telling, that acetylene, the earlier process was the liquid phase hydration of the acetylene, dehydrogenation of the partial oxidation of the ethanol. That is the process where the ethanol is available from the molasses route. They are using oxidation of the butane, propane mixture, liquid phase oxygen of the ethylene. The last process, that is from the petrochemical point of view, that is very important, and this is because we are getting from the your C4 gases you can get, or from the natural gas you can separate, and this can be used for the production of the acetaldehyde, because during this process of making from butane, propane, is number of the other chemicals are also formed. So, this is the various technology that is available for the manufacture of acetaldehyde. This is the acetylene route, liquid phase hydration of the acetylene, where you are getting the acetaldehyde. This process is no more, it is being used. Oxidation and dehydrogenation of ethanol. Ethanol route for the manufacture of acetaldehyde is being used by those industries where ethanol is produced through the fermentation of the molasses. There are two routes for manufacture of acetaldehyde from ethanol, that is the vapor phase oxidation of ethanol and dehydrogenation of the ethanol. This is the process that is taking place while the reaction, that the oxidation of the ethanol or the dehydrogenation of the ethanol. Acetaldehyde by liquid phase oxidation of the ethylene. Commercialization of the ethylene route for manufacture of the acetaldehyde began in 1960 and remains the widely accepted route because of the availability of the cheap ethylene from the petrochemical complexes, means the cracker plants. This is the reaction that is taking place in case of the liquid phase, again the pyrogen catalyst that we are using. Oxidation of the hydrocarbon, which I told you, the vapor phase oxidation of the hydrocarbon, butane, propane, butane mixture yields acetaldehyde along with a wide range of the chemicals including the formaldehyde, methanol, acid, glycol. So, these are all the mixture of the large number, and that has to be separated, and that was the actually the, because here we need the purification, the whole process is complex and highly specialized, and because of that reason that direct from the ethylene route, that is more preferred in case of the manufacture of the acetaldehyde. These are the some of the product profile of the acetaldehyde, and this is the pyridine and picoline. These are the two very important product even in case of jubilant organisms they are making, and which are finding use in the drugs, dyes, agriculture chemicals. And this is the, again you see the while discussing the coal chemicals, I told you the root of the pyridine and picoline even the through the coke oven plant also that was available, but with the coming of the development of this technology, now we are able to make from the ethylene root, from the acetaldehyde. So, pyridine and picoline, these are two very important valuable product of the jubilant organisms, which is being used for making of the agrochemicals. And then the chloraldehydes that is being used in insecticide, fungicide, disinfectants, acetal, paraldehyde, rubber acylator, antioxidant of the and in the dye stuff industry, peracetic acid, epoxidation reaction reagent in the caprolactam, then the synthetic glycerols, pentaethyl acetic anhydride, the acetyl salicylic acid, cellulose esters, acetic acid, lactic acid, which are different use of these products are there, but the starting material that may be from the that is from the acetaldehyde. These are manufactured. I am not going in detail each and every product which we are getting, how we are getting from acetaldehyde, but these are the various products which are available and they are finding wide application. This is the importance why we are making the acetaldehyde. Acetaldehyde is considered one of the very important derivative of the ethylene so far the chemical industry is concerned, because so far the PVC or the polyethylene is concerned, that is going to the polymer industry, but as a chemical feedstock, this is the importance why we are interested in the acetaldehyde. So, we discuss about the ethylene derivatives. Here I did not discuss the cracker, already we have discussed how we are getting the ethylene from the cracker plant. The next lecture will be another important petrochemical that we are getting through the from the cracker plant, that the propylene. Propylene, that is one of the very important, where the same the main various products which are getting the same propylene oxide as ethylene oxide there, propylene glycol, but some of the other important products are also there propylene, because that is being used for the acrylonitrile, manufacture of the acrylonitrile, and so the what are the various routes for getting the apart from the your this cracker route, the dehydrogenation of the paraffin, that is another important. What are the various technology? Because one of the technology which is coming, which I did not discuss there, in case of the synthesis gas, that is the methanol to propylene, methanol to olefin technology. So, all these thing about the propylene, the on purpose means the propylene from dehydrogenation, propylene from the cracker, from already we have discussed. We will be discussing in that the how the propylene, what are the various technology available for the conversion of the paraffins to the propylene and the methanol to propylene technology, because that is going to the future source, very important source, because that will go along with the cracker plant, that is the methanol to olefin, because the natural gas where that will be used for the making of the methanol and methanol to olefin, and that technology also coming from the coal gasification route, coal to polymer, coal to plastic, that is the same route, coal to methanol and methanol to again we are going for the propylene. So, that is the technology available, and that is we are going to the China, they are going to have the coal chemicals where they are going to implement this technology, and in the future also we may see some of the plants which are based on the methanol to olefin technology. So, these are the things that we will be discussing in the next lecture, and that is the about the propylene and its derivatives.